Hello everyone. In today's lecture, we'll explore a critical component of modern technology that has revolutionized our world, the semiconductor. Semiconductors are materials that sit between conductors, such as copper, and insulators, like rubber, in their ability to conduct electricity. They have unique properties that allow us to control the flow of electricity under certain conditions, making them essential in the production of modern electronics. To understand the significance of semiconductors, let's start by looking at what they actually are. As I mentioned, semiconductors fall between conductors and insulators, and their ability to conduct electricity can be modified in several ways. At the atomic level, semiconductors have a specific crystalline structure. Silicon is the most commonly used semiconductor material because of its abundance and favorable atomic arrangement, which allows precise control over its electrical properties. Germanium is another semiconductor, but it is used less frequently because silicon is cheaper and easier to process. One of the most fascinating characteristics of semiconductors is that they can be doped. Doping is a process where small amounts of other elements are introduced into the semiconductor crystal to enhance its conductivity. For instance, when a semiconductor is doped with phosphorus, it gains an excess of electrons, creating what we call an N-type semiconductor. If it's doped with boron, which lacks electrons, it creates a P-type semiconductor. These two types of semiconductors, N-type and P-type, are the building blocks of many semiconductor devices. Now, how does this play into the devices we use daily? Semiconductors are found in countless electronic products, including computers, smartphones, and even household appliances. The transistor, which is essentially the building block of all digital circuits, relies on the properties of semiconductors. Transistors control the flow of electric current and can act as switches or amplifiers. They form the foundation of microprocessors, which are used to run complex programs on devices like computers and mobile phones. Without semiconductors, our world of digital communication, computation, and automation would look very different. Let's take a closer look at some devices that rely heavily on semiconductors. The diode, for example, is a simple yet crucial device that allows electric current to pass in only one direction. Diodes are used in power supplies to convert alternating current AC to direct current DC and are essential in radio signal detection. Another important device is the integrated circuit, or IC. An IC is made up of millions of transistors, diodes, and resistors, all embedded in a tiny chip. Integrated circuits are at the core of virtually every modern electronic device, from smartphones to televisions to advanced medical equipment. One application of semiconductor technology that has gained widespread attention recently is the solar cell. Solar cells use semiconductor materials, typically silicon, to convert sunlight into electrical energy. When sunlight strikes the semiconductor, it knocks electrons loose, generating a flow of electricity. This technology has played a significant role in the renewable energy sector, providing an alternative energy source that is both clean and sustainable. The importance of semiconductors extends beyond consumer electronics and renewable energy. They are also essential in the automotive industry, especially with the rise of electric and autonomous vehicles. Modern cars rely on semiconductors for functions such as fuel injection, braking systems, and advanced driver assistance systems or ADAS, which include features like lane keeping assistance, automatic braking, and adaptive cruise control. These systems require rapid data processing and precise control, which only semiconductors can provide. So, why are semiconductors so central to technology? The answer lies in their versatility and scalability. Semiconductor materials are adaptable and can be used in devices of all sizes, from microscopic microchips to large solar panels. Furthermore, advances in semiconductor manufacturing have enabled us to fit billions of transistors onto a single chip, significantly increasing computing power while reducing the size and cost of electronic devices. However, the semiconductor industry faces several challenges. One major issue is heat dissipation. As devices become smaller and more powerful, they generate more heat, which can impact performance and reduce the lifespan of the components. This is why cooling solutions, such as fans in computers or liquid cooling in data centers, are necessary to maintain the functionality of semiconductor-based devices. Another challenge is the demand for rare materials. Although silicon is abundant, many other materials used in semiconductor manufacturing, like gallium and indium, are relatively rare and expensive to extract. This dependence on rare materials has led to supply chain issues and increased costs, especially during times of global shortages. The semiconductor industry is continuously researching alternatives and recycling methods to address these challenges. In recent years, semiconductor technology has seen exciting developments. Quantum computing, for example, is an emerging field that seeks to harness the properties of quantum mechanics to perform calculations much faster than traditional computers. Quantum computers rely on specialized semiconductor materials and have the potential to revolutionize fields such as cryptography, artificial intelligence, and complex data analysis. In conclusion, semiconductors are indispensable in our world today. They provide the foundation for nearly every electronic device and play a crucial role in industries ranging from consumer electronics to renewable energy and transportation. As technology continues to advance, the demand for semiconductors will only grow. However, the industry must also address the challenges associated with heat, material scarcity, and the need for sustainable practices. Semiconductors truly are the heart of modern technology, shaping the way we live, work, and interact with the world around us.